What's up, guys? My first ever YouTube video, so bear that in mind and be patient with me. So my name's Shaq, and what we're doing today is something called the Pythagoras Theorem. Pythagoras Theorem is a theorem which states that there is a relationship between the three sides of a right-angled triangle. And Pythagoras' theorem only works with right-angled triangles. Bear this in mind, okay? And the theorem works like this. It's a squared plus b squared is equal to c squared. Let me explain what that means. And let's start with c. When we have a right-angled triangle, we can always label our triangle with an a, b, and a c. So let's start by labeling our triangle. C is always the hypotenuse, or the diagonal side, alright? So this will be C, and A and B don't really matter. A can be the vertical side or it can be the horizontal side, and B can be the vertical side or horizontal side, as long as C is always the diagonal side. And the theorem goes that the square of the A side, so A squared, plus the square of the B side always equals to the square of the C side. Okay? And let's see how we can use this concept in a problem. So, we have a right-angle triangle, and we got to find a missing length. Okay? In order to use Pythagoras, you have to first always make sure that this is a right-angle triangle. So, step one. Make sure it's a right-angled triangle, which it is. So, let's first label our sides. So, C is always our diagonal side, and let's call the vertical side A and the horizontal side B. It could be like that, or it could be B and A. It doesn't really matter, as long as the diagonal side is always B. Okay? So step one, we've labeled our three sides, and let's write down our Pythagoras theorem. A squared plus b squared is equal to c squared. Alright, so what's A? A is 12, so 12 squared plus b. B is 5, 5 squared is equal to c squared. Well, c is x, so x squared. Alright, let's simplify that. 12 squared is 144. Plus 5 squared is 25 is equal to x squared. 144 plus 25 is 169 is equal to x squared. So some number, x squared, makes 169. Well, in order to isolate x or get x by itself, the inverse of square is square root. So we're going to square root both sides. And we're going to square root this side. So, the square root of 169 is 13. And the square and the square root cancel out, leaving us just with x. So x is 13. And that's how we apply Pythagoras' theorem, guys. So, always make sure to remember, in order to use Pythagoras' theorem, you need a right-angled triangle. And you need to know the length of two sides. In this case, we knew the A side and the B side was 12 and 5. And we're trying to find a missing side. So, in order to use Pythagoras' theorem, you have to satisfy these three criteria. It has to be a right-angled triangle, check. We need to know the length of two sides, check. And we're trying to find a missing side. Cool. So we're not trying to find a missing angle, we're trying to find the missing side, okay? Let's go to the next question together. So, let's look at this problem here. We have to find the missing side. Okay, let's see if we can use Pythagoras together, guys. Well, do we have a right-angled triangle? Right-angled triangle. Yep, we do. Do we know two sides? Yep, we know the length of two sides. And are we trying to find the missing side? Yep, we are. So we can use Pythagoras theorem. So, what am I doing? What am I doing? Two sides. I'm missing side. So, let's first label our triangle. So, the diagonal side is always C, so C, A, B. Okay, and let's plug this in into our Pythagoras theorem. So A is 90, so 90 squared, plus B. Oh, B is x. X squared is equal to C. C is 3.5 meters. Well, if our A value is in centimeters, let's make sure our C value is also in centimeters. So 3.5 meters is also 350 centimeters. So C is 350 squared. All right, let's solve this slowly. 90 squared makes 8,100 plus x squared is equal to 350 squared is, I have no idea, 122,500. All right, now we have to solve for x. Well, let's solve by rearranging. So x is being squared, then being added by 8,100. So we always work backwards. So we're going to subtract 8,100 from both sides. So this cancels out, leaving us with just x squared is equal to 122,500 minus 8,100. 114,400. All right. To get rid of the square, we must square root both sides because the opposite of squaring is square rooting. So we're going to square root both sides. All right. So the square and the square root cancel out. Boom. Leaving us with just x is equal to, and the square root of 114,000 is it's obviously 338 cm. Great. So x, our unknown, is 338 centimeters, and that's our answer, guys. All right, let's do the next question together. All right, a word problem. Okay, so this is a pretty common exam question, guys, and let's read through it together. A 9-meter ladder is placed against a wall. The foot of the ladder is 1.5 meters from the foot of the wall. How far up the wall does the ladder reach? In a question like this, I always recommend drawing a diagram, all right, to help us visualize the problem. So, a 9-meter ladder is placed against the wall. So we have a wall. I'm assuming it's going to be vertical. And there's a ladder being placed against it. All right. So the ladder is being placed against it. It must be diagonal. So this is our wall. This is our ladder. And the ladder is 9 meters. The foot of the ladder, over here, is 1.5 meters from the foot of the wall, which is over here. So this length here must be 1.5. How far up the wall does the ladder reach? Well, we're looking for this length. So let's call this x. We're trying to find this side. All right, guys, what do we notice? Well, this is definitely a right angle triangle. All right, now we think, can we use Pythagoras' theorem to solve this problem? Let's go back to our criteria again. Well, for our criteria, we need a right angle triangle, which we have. Right angle triangle. We have two sides. We know two sides. Yeah, and we're trying to find a missing side. We can definitely use Pythagoras here. So, let's write down our Pythagoras theorem. And let's first label our triangle. So, the diagonal side is always C, and let's call the vertical side A and the horizontal side B. And let's fill out our theorem. So, a squared, well, a is x, so x squared, plus b squared, b is 1.5, squared is equal to c squared. Well, c is 9, so 9 squared. Let's simplify this slowly. X squared plus 1.5 squared is 2.25 is equal to 9 squared, 81. All right, let's solve this by rearranging. Well, x is being squared, then being added by 225. So let's subtract 2.25 from both sides. So now we have x squared, this cancels out, is equal to 81 minus 2.25. 78.75. All right, to get rid of the square, we must do the inverse, which is square rooting. So let's square root both sides. All right, the square and the square root cancel out, leaving, that was pretty poor. The square and the square root cancel out, leaving us just with x is equal to the square root of 78.75, which is 8.87. So that's our answer, 8.87. Because x is equal to 8.87, we called our side x. So this must be 8.87 meters. So the ladder reaches 8.87 meters high off the wall. Okay? Let's look at our final question. Ooh, this one looks pretty saucy. So we have to find this missing side. Okay? So how would we approach this problem? I see two triangles. Well, let's start looking at a triangle which has the side we're missing. Let's start with this bottom triangle. All right, let's see if we can satisfy the criteria for Pythagoras for this triangle. So, first, it's a right angle triangle. Great. What's the problem, guys? In order to use Pythagoras, you need to know two sides, but I only know one side. In order to find this side, I have to know this side too. All right? So therefore, we can't use Pythagoras straight away to find this unknown side. So what can we do, guys? Well, maybe we need to find this side. Well, let's have a look at this top triangle. All right. Maybe we can use Pythagoras here. Well, is this a right angle triangle? Yeah. Do we know two sides? Yeah. Know two sides. Are we trying to find a missing side? Yeah. Oh, great. We can use Pythagoras on the top triangle. All right. So I'm going to redraw this top triangle myself. So this side is 13. This side is 19 centimeters. We're trying to find this side. All right, guys. And this is side point D, C, and B. Okay, let's start by labeling our triangle. A lot of people get confused at this point because they see these letters here and we're like, oh man, yo, what is this side still C? Is this side still A and still B? They get confused. And yes, ignore these stupid letters, okay, guys? Ignore it. Our diagonal side is always still C, no matter what. And our horizontal and vertical sides can be A or B. So we'll write A and B. All right? So since we've realized we satisfy the criteria for Pythagoras, let's write down our theorem. All right? And let's fill in the blanks. Well, A is 13, so 13 squared. Plus B, well, B we don't know, so it's x squared. That's what we're trying to find. It is equal to C squared. Well, C is 19, so 19 squared. Let's solve this. 13 squared, do 169, obviously. X squared is equal to 19 squared. 361. All right. So So now we're trying to find x. Let's try and get x by itself. Let's try and isolate x. Well, x is being squared and then being added by 169. So let's work backwards. We're going to subtract 169 from both sides. All right. So that will cancel out that. So x squared is equal to 361 minus 169. All right, and now to find x, we have to square root. We have to do the inverse of squaring. So x is equal to, square root of that side, square root of 192, which is 13.8. So we know x is 13.8. So we now know, let's label back to our regular diagram. This side here is 13.8 centimeters. All right, guys. Now, we're trying to find this side over here. Can we use Pythagoras now? Well, we have a right angled triangle. We know two sides now, and we're trying to find a missing side. We can use Pythagoras. So, let's draw this triangle below again. This is 5 centimeters. This is 13.8 centimeters. Excuse my poor handwriting. And this is x. We're trying to find this side. And label this is A, C, A, B. All right, same as before, guys. Ignore these stupid letters, all right? They're irrelevant. The diagonal side, when we're doing Pythagoras, is always C. So C, and we'll call this A and B. Let's use our Pythagoras, which I'm sure you're very well acquainted with now. So, A squared, well, A is 5, so 5 squared. Plus B squared, well, B is x, so x squared, is equal to C squared. Well, C is 13.8, so 13.8 squared. 5 squared is 25, plus x squared is equal to 13.8 squared is 100, let's just say it's 190. All right, so let's work backwards. So x squared plus 25, so we're going to minus 25 from both sides. So we have x squared is equal to 165. And then to find x, we have to square root both sides. So x is equal to the square root of 165. So x is equal to 12.8. Let's go. So x is 12.8. So this answer here is 12.8, and we've solved this problem, guys. Cool. Let me know how that was. I hope that helped somewhat. And yeah, thanks so much.